what are the use of HA1, HA2 and HA3 interfaces in your, we can say, high availability. Okay, so let me just draw one diagram, guys. Here we are having Palo Alto Firewall, we are having another Palo Alto Firewall, second Palo Alto Firewall. Okay, now both these firewall have a connectivity like this. This is your HA1 interface. We will have another interface, HA2 interface, and HA3 interface is also there. So generally, this HA1 interface is also known as a like control link. Okay, so the thing is, this HA interface generally we use for exchanging. They will use in high availability. They will use for exchanging the configuration, guys. So configuration replication happens through this HA1 interface. Through this HA interface, they will also exchange the hello messages. Hello message. They will also exchange the keep alive messages through this HA1 interface. So these hello message and keep alive message, they will just exchange between each other just to know other device is live or not. And they will also basically exchange these messages just to tell the state of each other. So these are the main things basically performed by this HA1 interface. So we will generally have a like HA1 interface and also HA1 backup interface just for the backup purpose. Okay, this HA2 interface is generally that interface is known as like data link. And through this interface, basically both the firewall they will exchange the data like session information, session table details. They will exchange. They will exchange the MAC address table details. They will exchange the ARP table details. They will exchange the IPSec assay details. If we have configured the IPSec site-to-site VPN, they will exchange these details. Okay, so generally due to this HA2 interface only, we will able to configure the stateful firewall. So means if due to any reason, if this device which is in active state, if he become unavailable, then this device become active. That time basically whatever success, whatever users we are having, they don't need to initiate, we don't need to re-initiate the session. They will just this particular firewall just serve the request of which is coming from this PC by using these particular information, this session detail information. Okay, this HA1 and HA2 this HA3 interface generally we use when we are running firewall into active mode. And the thing is that HA3 interface just basically this interface used for exchanging the packets between this active primary firewall and active secondary firewall. This is active primary, this is active secondary. So let's suppose, because in active scenario, one firewall become like session owner and one firewall becomes session setup. Okay, so the thing is now they will exchange the packets between these firewall who become the session owner, who needs. So let's suppose for one packet this firewall becomes session owner and this firewall becomes session setup, right? So this firewall basically just perform the all your layer 7 functionalities, and session setup firewall will perform your layer 3 to layer 4 functionalities. So the thing is, if your packet wants layer 3 to layer 4 functionality, in that case this firewall basically will work and you are receiving the packet on this one. So that packet they will exchange through this HA3 interface. Packet reaches to this firewall. Now this firewall it is like session setup firewall, so he will just process that packet for layer 3 and layer 4 checks, and after it will again send back this packet to a Palo Alto Firewall 1, and this firewall perform layer 7 functionalities. Again that packet go to here and it will just exit out from the exit interface. So these kind of information they will exchange through the HA3 interface, guys. So these are the, we can say these are. And also now I want to also tell you one more thing, guys. Here either we will have a like dedicated interfaces as a HA1 interface, HA2 interface and HA3 interfaces. Okay, but If we can also use a data interfaces as a HA1 and HA2 interfaces. We can configure data port as well as a HA1 and HA2 interfaces, guys. Okay. And also HA3 interfaces. So these are your HA1, HA2, and HA3 interfaces in case of your Palo Alto firewall. Now, let me just come back to the question number 6, guys. Question number 6 is, what is the prerequisite for HA configuration, right? So generally, if you want to put two devices into an HA pair, there is some prerequisite. So there are mainly three types of prerequisites. First one is your hardware related prerequisite. Hardware requirements. Second thing is software requirements. And third thing is license related requirements. Okay. So if when we discuss with this hardware related requirement, which means both firewall will have a same model number. Same model number, guys. Let's suppose we are having PA 850, then other end also need a other firewall is also 850. We will not allow to configure HA between 850 and PA 820. We will not able to configure, or maybe 860. We need a same kind of model number between both the ends, guys. Now if we are having same model number, definitely we are having same type of interface. Just remember, if we are having same model number, then we have a same number of interfaces, and type of these interfaces also similar, guys. So these are the mainly hardware related requirements. Now software related requirements we have, so means both firewalls will run same operating system, means same version of OS. Let's suppose in one firewall we are running 9.1.3 and another firewall is running 9.1.4. We will not able to we will able to configure the HA in that case, but one device go into the suspended state. So we need a same major and minor version of operating system. Okay, so this is the software requirement. Now we do have a hardware requirement. We will have a like license requirement as well, which means both devices should have a same kind of license. Both devices need a same kind of license. So let's suppose your Palo Alto firewall one have a threat prevention license. In that case, Palo Alto 2 also need a threat prevention license. If Palo Alto one have a, we can say, wildfire license, then other end also need a wildfire license. If PA2 have a URL filtering license, then other five also need a URL filtering license. So these are the prerequisite for HA configuration, guys. Okay. Now let me just move towards the next question, which is your what is service route? What is service route? So let me tell you guys what happens if you know we have a few kind of server. Let's say we are having NTP server in our organization. We will have a DNS server in our organization. We have a like syslog server in our organization. We have a like radius server in our organization. We have a like LDAP server, which is your AD server in our organization, right? All these kind of servers generally we have in our organization, right? Now, there is so many things, right? Now, so the thing is, we have a like our Palo Alto firewall. That Palo Alto firewall have a management interface, and this management interface have a let's say connected with switch one. This is the management switch, okay, and this is the maybe Ethernet 1/2 interface, which is connected with your layer 3 switch. Okay, now because these are the servers, right? And maybe some point of time this switch have a connect with this L3 switch, and that switch have a connectivity with all these servers, right? So now the thing is, by default Your Palo Alto firewall, if your Palo Alto firewall wants to communicate with NTP server to for synchronizing the time. Let's suppose we have configured FQDN on our or on our firewall. Now my firewall needs to resolve some names. Then he will send the request to DNS server. So, and also let's say my server wants to communicate with syslog, then he will basically send the syslog message to syslog server. Let's say we are using radius authentication, then my file needs to send some packet to radius. Let's say we have used the user based policies. In that case, my firewall also needs to do the query on AD server, right? So all this kind of traffic basically sent through the management interface, guys, right? All these kind of queries is sent to the management interface. And now this particular thing is known as a service route, guys, because management interface we will use for sending all these requests. Now let's suppose this is my inside network. Okay, this is my management network. Now due to any reason I don't have a connectivity of this management network through these servers. These servers is only reachable through this ethernet 1/2 interface, through my through this interface in my inside network. In that case, we have to configure the service route, guys, on my firewall. So instead of, because by default my firewall uses the management port for just communicating with these servers, right? Now we will configure the service route on this one. If my server wants to communicate with NTP server, we will just point out the IP address of NTP server, and we'll just point out this interface. He will need to send this traffic through this interface, Ethernet 1/2. If my firewall wants to send the DNS queries, in that case, DNS is behind this interface, so we have to modify the service route for DNS server. We have to modify we also need to modify the service route in case of radius server. We have to define if my firewall wants to send any request to radius server, just forward this request through ethernet 1/2 interface. So these kind of modification we have to do into service route, and this is the thing which is basically you these are the things which we have to understand with regards to service route. Let me just show you. Just you if you go to into your device tab, okay, into services, you will see service route configuration, and see if you want to communicate with the autofocus, what it will use the default interface, which is management interface. Email DNS is right now, see I have configured one service route. If my firewall wants to send a DNS request, he will just forward through ethernet 1/2, and this is the IP address of my inside inter, because I am having DNS server in my inside network, right? So like that you have for AD also, because I'm also having AD in my inside network. So I just change the service route for this LDNS. Let's suppose I'm having NTP server also in my inside network. What I can just define that interface, define that IP address. That is the one thing I can do. Or either what I can also add a right click. If I want to communicate with this IP address, always my firewall forward the request through this Ethernet 1/2 interface. Instead of using management interface, it will use Ethernet 1/2 interface IP address. This is, guys, your service route. Okay. Now the next question is, what is application identification, guys? What is app ID in your Palo Alto firewall? Okay. Or what is app ID and what is application override policies? So let me tell you guys what is app ID. So when Palo Alto basically come in the market in 2005, like Palo Alto launched in 2005, and basically that time Palo Alto is only the single fire who have a features like app ID, like content ID, and like user ID. These are the main three features which is introduced by the Palo Alto during that time. So what happens in app ID? When my Palo Alto file receives a packet, whenever my Palo Alto file receives a packet, this is PC1, this is server1. Okay. Whenever this PC wants to communicate with the server, what it will forward this request to Palo Alto. Now, when Palo Alto receive this packet, what it will just process this packet through the ingress check. Then it will send this packet through the connection setup state, because it's a first packet. And after that, basically, it will install the connection into the connection table. Now, it will basically send that packet to the app ID engine. And now basically in app ID engine, application identification happens, guys. on the basis of signature database. So like app ID engine having some kind of signature database, so it will basically just check that particular traffic against these signature database, and it will just try to and my firewall just try to identify the application for this file. So let's suppose this server is hosted over port number 80, right? It's a web server, right? In that case, my firewall able to detect this traffic as a web browsing traffic. Let's suppose we do have a like torrent here. Let's say this PC is trying to access this torrent. In that case also, what my firewall basically send, when my firewall send this torrent traffic to app engine, my application identification engine basically able to identify, because he is having intelligence enough to identify, oh, this traffic is related to the torrent traffic. And also by using this app ID, we can control the traffic on the visa applications, guys. Let's suppose we want to block the torrent traffic, we can block right away. If let's say we want to block the Facebook chat or Facebook video call, but we want to allow the actual Facebook, but we want to block the chatting, Facebook posting, Facebook video calling, audio calling, all these kind of things we can block, because all these are the applications. We will just allow the Facebook base, so my users can able to access the Facebook page, but they will not able to make any kind of chats, they will not able to make any kind of video and audio calls through the Facebook. These kind of controls we will get by using the app ID, guys. Okay, so let me just explain you the application, how app ID works in your Palo Alto. So I'll just take up one picture, guys, for that. And also let me just also explain you this thing as well, guys. What happens in Palo Alto Firewall due to this powerful app engine in your Palo Alto Firewall? What happens in old days? Let's suppose you are having one legacy network, right? So that you are having Yahoo Messenger, BitTorrent, right? By default they used to run on port number 5050 and port number 6681. Okay, these are the default port number for BitTorrent, for Yahoo Messenger. And let's suppose if we have open port 80, so what these Yahoo Messenger, BitTorrent, they can do, they can just do the they will just scan this firewall on which basically what kind of rules is allowed, and after what they will switch their port numbers. Maybe they can start running on port 80, and basically that kind of traffic go through our firewall. This is for legacy firewalls. Okay, because legacy 5 inspect the traffic on the layer 3 and layer 4 information. But in case of Palo Alto, what happens if BitTorrent, let's suppose BitTorrent is, we have allowed the DNS traffic, let's say BitTorrent is also start using the DNS UDP 5000 UDP 5353 port number. So in that case, what my Palo Alto firewall basically detect, oh, this on the on looking on the layer 7 header of this traffic, he will get to know this is the BitTorrent traffic, it's not a DNS traffic, and it will just block right away. But here what doing, BitTorrent is running on DNS, but my firewall is basically inspecting the traffic on the basis of layer 7 information, guys. Okay, so here it will right away block the BitTorrent traffic. So this is also like, this is the design where we have allowed DNS traffic, we have allowed BitTorrent traffic, right? But let's suppose through this BitTorrent is allowed, but BitTorrent is blocked, and we are blocking at the IPS level in case of legacy design. But let's suppose someone is trying to send this command and control kind of attack. Maybe that kind of attack is not detected by the IPS model. But in case of Palo Alto Firewall, if BitTorrent will start running on 53, my Palo Alto will block this traffic at the application level. And also if someone trying to access this particular, try to exploit this command and control, he will also be able to block this particular traffic. So these kind of basically control you will get by using the application identification. Let me explain you the how basically application identification operation works, guys. Okay, so in app ID, what happens when my Palo Alto Fire receives a packet? Okay, what it will extract the IP address, and it will extract IP and port numbers, and it will check the security policies at the connection setup level. Okay, it will check the policy at the connection setup level. Okay, and here it will just consider application is any. Okay, and after it will send this traffic. So let's suppose this policy is allowed the traffic for application is any. on the basis of for source IP destination, let's say we are having allowed rule, right? Now this traffic reaches to the my firewall. Now my firewall first check the known protocol decoder. In this particular traffic, it will just look for known protocol decoder, and it will just try to match this traffic against the application signature. For unknown protocol decoder, let's suppose there are some kind of unknown application traffic. In that case, it will decode that traffic for against the unknown protocol decoder, and it will just forward this traffic for the application signature. If application signature match happens, in that case, basically, now let's suppose my firewall is basically find this is the DNS traffic, and we have allowed rule for the DNS. So my file allow this traffic. Let's suppose my file detect that traffic as a torrent, and we have block rule for torrent. In that case, it will block the traffic. Sometimes what happens nowadays, people's also like torrent and all the Yahoo Messenger, these kind of all other malicious website, they will also uses HTTPS. So now when they will basically use as HTTPS, so when any users can connect with these servers by using HTTPS, so whatever data they will send through this tunnel, it is in encrypted form, and my firewall will not able to detect. In that case, what my firewall also do the decryption on this particular traffic. He will decrypt, apply the decryption policies, decrypt it again. It will match that policy against the signature database, and he will just forward this traffic towards for this application signature or through the app ID engine one more time, guys. And application identification happens. So it's the same thing. First traffic, they will basically match the traffic against the identified by the applicant signature. If app ID happens, then it will take the action according to the policy. If no, then it will just match the traffic against the known protocol decoders. If application match appli ID happens, then it will take the action according to security policy. if if it's, let's say it's not a known protocol, now it will do the heuristic checks. Means it will just guess the application and it will use some kind of uncertainty factors and all to identify the application. for n- for, for like, let's say now my firewall is not able to identify as unknown traffic. In that case, that application identification as unknown, and whatever rules we have configured on our firewall, it will take that action accordingly. So this is the application over, this is the basically app ID things. This is the way how application identification happens, guys. Okay. Now let me also show you what are the things they will check. So the thing, if you have seen, this is the format for, this is the traffic for UDP. In UDP, basically these are the things checked by the firewall for. This is the application data, and this data is basically parsed through your application identification engine just for identifying the application. In case of TCP send packets, basically this is the data which is used by my firewall for application identifications, guys. Just try to understand this thing. Okay. Now, if you let me also explain you application shift, how application shift happens, because this is also important, guys. Sometime, so what happens? Let's suppose you are sitting here, and this is the web server, and this is Palo Alto Firewall, right? So what happens? Let's suppose you have just opened one URL which is www.facebook.com. So first TCP three-way handshake will complete, and after that, basically your HTTP request will go till this server, right? So when this HTTP request will receive by the firewall, so the thing is my firewall detect this communication as a web browsing traffic. After that, because Facebook is hosted as HTTPS, so now they will basically switch over that particular communication over SSL, right? So now my firewall basically detect this application as a SSL application, right? After that, when you will receive some kind of data for Facebook, right? So my firewall detect, oh, this application is a Facebook application. Now later on, what you have done, you have opened the chat application on that Facebook, and you have just start chatting. So later on, this application basically detects a Facebook chat. So these kind of shift is also happens. But here the end application is Facebook chat, right? But Let's suppose this Facebook chat is not available. Okay, due to any reason you are not able to open this Facebook chat. Maybe this particular server become unreachable at the Facebook level due to any reason, right? In that case, maybe you in your logs you will see your date you in logs basically you will see you are trying to access the Facebook base. This kind of things as well you will see. So just when you are troubleshooting, just try to make sure all these things. There's a application shift happens, guys. Okay, during the application identification. Okay, now let me just quickly explain you the application override, guys. So in application override, what happens? So let's suppose you are having few applications here. This is your F1 and this is your application 2. You are having your Palo Alto firewall, and this firewall have a connectivity with different branch offices. Branch office 1, branch office 2, and branch office 3. This is your switch, and you are having this is your app zone. Okay, just give the app zone. Here you are having your inside zone. There you are having multiple systems in your inside zone, right now. This is your switch. Behind this you are having multiple users. Now the thing is, just try to understand. Let's suppose if people who is sitting behind this branch of it, they want to access these applications, because these are your applications, guys. These are your apps, right? These are the apps created by you only for just some internal business purpose. And people who is sitting in behind your branch office, these are your peoples, right? We can trust on these. They are our employees. We can have a trust on them. So let's suppose if they want to exchange this application 1 or like application 2, what happens when my Palo Alto Fire receive these packets? Every time he needs to send this particular data through the app ID engine, right? He needs to do the application identification. So the thing is, but because these are your apps and these are your users, you don't require this application identification, because whenever your Palo Alto Firewall forward this data through app ID engine, it will app ID engine needs to process this data, so it will basically consume some resources and it will take some time for processing that data, right? But you have a trust on these application and your peoples, right? So in that case, you can also able to bypass this application identification engine for this particular traffic, guys, coming from these branch office users towards these your application. You can bypass the app engine completely by writing the application override policy. So this is, guy, your application override, where if you are having your internal applications and these internal applications you are using some kind of internal business purpose, and these applications also is accessed by the internal users only. In that case, you can just completely bypass the app ID engine just to enhance the throughput and processing. We can say we will enhance the throughput and we will also reduce the processing of app ID engine. Okay, so this is your application override, guys. Okay, so this is all about today, and in next session we will take few other questions with regards to Palo Alto. If you want more details, if you want to know more about us, just visit our website, which is www.cnnets.com.